Hello everyone, this is our next video of IPSec series. In the today videos, we are going to discuss IPSec fundamentals, and the today topic is authentication header. So let's discuss authentication header. So what is authentication header? one of the IPSec security protocols provides integrity protection for packets, header and data, as well as the user authentication. It can optionally provide reply protection and access protection. Cannot encrypt any portion of packets. So the it provides a secure. It's a basically IPsec security protocols. It provides the integrity protection of packets and headers, but it also authenticates the packet, but it's not provide the encryption of the packet. So let's say this is your packet, TCP packet. So this whole packet will be authenticated, but it will not encrypted. Now the IP protocol number is a 51. So let's discuss with the modes. So is having two modes, transport and tunnel. In tunnel mode, creates a new IP header for each packet. In transport mode, does not create a new IP header. So is having two modes. In the one modes, if you see, this is having transport mode and this is having the tunnel mode, and this is the original packet. So this is the original packet. In the transport mode, you can see that we are on like this header is added on the in the case of transport mode, but in case of tunnel mode, header is added but new IP header is also added. So what is the difference between the tunnel mode and transport mode? So the difference is, in the case of transport mode, header is added on the TCP packet, but in the case of tunnel mode, this header is added plus we have a one extra header we called as a new IP header will be added. So in the IPsec architecture that use a gateway, the true source or destination IP address for packet must be altered to the gateway IP address, because transport mode cannot alter with the original IP address or create a new IP header. Transport mode is generally used for host to host architecture. So basically we have a VPN architecture. So I just created a video about the VPN architecture. If you have not watched, then just watch that video, then you will understand the architecture of the VPN. So for now, let's open my whiteboard. So what is meaning of this? Let's say we have a two sites. So this is the site A, and now this is a site B. So we have created and this is the ISP network. So via ILL, I would say that ILL on the both side, we take in the connection from ISP. So basically this is the gateway to gateway architecture, and we have that LAN subnet here 1.1.1.1, and here we have also subnet, let's say 2.2.2. the IP address could be anything, that 192 series or 172 series, whatever it is on the private range. So now here we have a one user which is having the IP address of, let's say 1.1.1.10. Now here we have a one web server. Okay, so in this server we have the IP address of 2.2.2.10. Now let's say this user A want to access this web server which is on site B. So what will be the original packet created by this PC? So this is the TCP packet. In this TCP packet, the PC will put source IP and the destination IP. So now the source IP will be the 1.1.1.10. what will be the destination IP? The destination IP will be this 2.2.2.10. And here the other field we added the source port and the destination port. So source port could be anything like 65535, the range, and the destination port, this could be anything, let's say 1 2 3 4 kind of thing. And now this is the web server, so we assume that this is running on 443. So now this is 443, so this is our TCP packet. So this packet will forward to this VPN gateway device. So this VPN device gateway, what this device will perform, they will add one extra IP header. So I can show this here only, and that they will this VPN device will replace the source IP with the public IP with this. Obviously encrypted. Obviously the VPN gateway will encrypt the data in case of ESP, and in case of H it will not encrypt it, but it will be authenticated using the pre-shared key that we used on the IPSec, and we'll discuss on more end, but let's focus on this. So in this case, this VPN gateway, they will put source IP. Let's say we have a 192.168.10.1, and here we have a 192.168 and 10.2, so that they will be reachable. So in this case, this is the source IP and this is the destination IP, which is reachable by, which is altered by this VPN gateway. So on the source type, they will add this IP address. So now after alteration of the packet, it looks like the 192.168.10.1, it will become a source, and 192.168.10.2, it will become the destination. So that packet will be forwarded to this VPN gateway. So if you notice, so these IP will keep remain same, but they will add a one new IP header here. So I just remove it so that I can show something. So I just remove this PC, so I can add another color. So what the VPN device is added, they added another new IP header with this source and destination. They will put the source IP is this interface IP, and the destination IP will be the distance in interface IP, and this packet they will forward to the ISP. So once we receive it, so this information is already on the packet. As on the VPN, this packet is not visible to anyone, so no one can see that what is the real source and what is the real destination. Only this VPN gateway knows about it. So once the packet return it, it will again go to this source IP and this destination IP. And this is for the addition of this new IP header is only possible because of we are using AH as a tunnel mode. So in the tunnel mode, the new IP header will be added. So the purpose of new IP header, I just explained that why this new IP header is required in the case of tunnel mode. So we covered this point, and it is visible here that in the case of trans mode, the only H header is added. In the case of tunnel mode, AH header and new IP header is added. So let's discuss more. I just zoom in. So this is the original packet which looks like. Give me a minute to fix it. So this is the tunnel mode. This is the tunnel mode per packet. So this is the original IP. This is the original packet. This is the original packet, and here you can see that the protocol is equal to TCP, and after it is encrypted with after is authenticated with the AH, there is a new field is added, next is equal to IP. So basically this is the real packet. So after it is authenticated in the AH mode, so this protocol is equal to TCP will replace with the next IP. So this field is added, next is equal to IP. And here this is the protocol. Let me change to the another color. And this is the protocol. You can see this is the protocol field, and here it is mentioned that name IP type. So protocol is equal to authentication header AH, and this new IP field is added, and this will be altered by the VPN gateway. And this whole packet is yellow because of this whole packet is authenticated by the AH. That is the reason it is marked as a yellow. So other fields it's also added, that's SPI, that security parameter index. So basically this is also a topic which I will cover. What is this? And they will have the sequence number, and this is the TCP header, and others are the original IP header. If you notice, we have this source IP address and destination IPs, and here is also source IP address and the destination IP address, because in the tunnel mode we have to add the one new header of the IP address. So this was the packet where I have explained that protocol is equal to TCP, and the new header, this is the AH header, you can say, and this is the IP header, and this is the original packet. So this AH header is added on this packet, and their next IP, and we'll get the source IP and destination IP on here, and other is also there. So now in the case of this is the original packet. So now I'm talking about the AH transport mode. So here this is the original IP headers, and if we can see that protocol is equal to TCP is still protocol is equal to TCP in the AH header. Here it's not the IP, here it is the TCP. That is the reason new header is not added on this packet, and the source and destination remains same. So we are not adding any new header in the case of transport mode, because on the protocol field on the TCP packet still on the next TCP, it is not set to the IP, and this whole packet is authenticated by AH only. So it is because they are adding a new IP header, because it's a mention on the packet, so that here the next response will be the IP, and but in this case it is the TCP. So in the case of TCP, there no extra header will added, only AH header will add, no IP header will add. So this is the packet related to the transmode of the AH. So this is the video related to the authentication header or AH, and we discussed deeply about the two modes of the AH. So I hope you enjoyed this video. If you enjoy, please hit the like button and subscribe the Firewall Experts for the upcoming videos. Thanks for watching Firewall Experts.